Hello.
Hi, you.
Hi.
New car?
Yes, we just got out of the dealership like a minute ago, so I'm sorry for the delay. We were there for much longer than I anticipated.
Sure. What kind of car?
We got a Subaru Forester, brand new.
Way to go.
Thank you.
So my cousin Gwen is with us.
Okay.
Okay.
Yes.
And
Then-
watched the movie this week.
Deb,
And
welcome.
what about,
You still
thanks.
getting better?
Yeah. The original symptoms mostly are gone. 99%. And of course it hurts, but nothing I can't stand.
That's good to hear.
Yeah, thanks. Rocky's, the whole team up there really walks on water.
Yeah, they're a great team.
Yeah, and
Well-
I did, mention you and Owen. Well, Owen and you.
Mhm. Good.
Yeah.
What kind of car did you get, Ryan?
We got a Subaru Forester.
Good car.
Mhm.
Deb drives that. You're doing that, right?
I drive, not the Forester, but the wagon Legacy. I
Outback.
think. Yeah,
Yeah.
Outback.
Mhm.
So Stuart, my cousin Gwen is here.
Hey, I saw
Hey,
you
hi.
at her birthday a couple of years ago, 3 years ago.
Yes.
Hi.
So she has,
At number
Been-
70, right?
yeah. Thank you very much. Yeah. I've always been the harbinger of your doom.
Yes.
Because he's younger than I am.
Oh,
Well, good seeing you.
All right.
And Owen?
Yeah,
Okay,
she's
go
going to
in.
join in a bit. We were late too by 2 minutes, but so I was because we got stuck on Route 22 traffic like Deb did a couple of weeks ago. It's just awful down there.
Nuts, huh?
Oh, yeah, it does get really bad at rush hour, doesn't it?
It's like a real
Uh-huh.
city rush hour. It's even worse.
Yeah.
Yeah.
So, Midnight Sun,
Midnight Sky, yes.
Midnight Sky.
Mm-hmm. Let me go ahead and share my screen here. All right. Well, a movie is based on trying to find, or at least in the beginning, trying to find habitable places to live. So the search for exoplanets has always been a thing that astronomers work on constantly. And my question was, we found, I think, probably thousands of exoplanets. I think that's an appropriate order of magnitude. We found so many exoplanets, and out of all of the ones that we've uncovered, which ones are the most promising to habitability or sustaining life if we were to move there? So there's two questions to this. We find exoplanets that, let's say, are in the Goldilocks zone and have similar characteristics as Earth. And we ask, does life exist there already? And even if life doesn't exist there, could we inhabit it no problem, just like we do Earth? And I think there's
Or terraform it.
that's right, terraform it. I think a lot of the Earth-like exoplanets have been named with the prefix Kepler. So you look at this list here, it goes Kepler 186, Kepler 452, Kepler 10, and this one, Kepler 1649c, looks pretty much identical to Earth, minus the color. It's pretty much exactly the same size, and it even has an atmosphere very akin to it. So if we go,
The color is important because that's water.
yes. But so this might be a good answer to the question I posed in the PowerPoint. Of all those exoplanets, which one is the most suitable to harbor life. And it's been written that Kepler 1649c is the most similar planet to Earth found so far by the Kepler telescope.
This is
And
not the
look-
Trappist. The Trappist one. This is not it. Or is it?
What's the Trappist, Stuart?
Well, I thought there was something about recently in the last year that I remember hearing about Trappist. Does that ring any bells or not?
I don't think I've heard of
TRA.
Trappist 1.
I don't know.
Like the monks?
Well, I just,
Oh, like another solar system.
yeah, there it is. That one.
Trappist 1 system. Oh, okay. So now we're talking not just a planet similar to Earth, but an entire planetary system similar to the solar system.
Mhm.
And they named the exoplanets A through H, it looks like, or B through H. I don't wonder what happened to A. This is really interesting. I've never learned about this.
I think it's been the last year. I remember seeing it.
Oh, wow. Okay.
Remember hearing something, but not the name.
Belgian astronomers discovered 3 of the planets 6 years ago, and then they found additional planets 2 years later. And they said up to 6 of these planets could be in that Goldilocks zone, C through H. And so just like the Kepler 1649, the host star is a red dwarf, it appears to be.
Mhm.
So in this one, it's an ultra cool dwarf. And that's probably the reason why you have such a large Goldilocks zone. And then we go to Kepler 1649. Its star is a type M red dwarf. So let's say we were to colonize this Kepler exoplanet, we would find that we could probably live there for a far longer period of time than here on Earth, because our sun is burning through, or is it burning, using up its fuel more rapidly than lots of dwarf stars, because dwarf stars tend to have lifespans way longer than stars like our sun or red giants, which are even shorter. So our
Why?
sun is probably going to be around for another 5 billion years. Red dwarfs can live on for hundreds of billions of years.
Why? What's the characteristic of a red dwarf that permits it to do that?
Okay. So the larger the star, let's say a star like Betelgeuse, it's so huge, it uses up its fuel way faster. You can think the brighter the candle, or is it the brighter the flame, the quicker the candle, or something like that? I forget the analogy. The quicker
Yeah.
it burns out, basically. So larger stars expend much more energy more rapidly than smaller stars.
Hmm.
And that's just characteristic. It's inversely proportional to its size. So the larger the star, the shorter its lifespan. We say that Betelgeuse, for instance, is nearing the end of its life. It's very close to dying, but Betelgeuse only was born less than 200 million years ago.
Wow.
As opposed to 5 billion or something.
That's right. Yeah. So Betelgeuse came in late and is going out early because its lifespan is only a few 100 million years. And then our sun is like a middle-aged, middle lifespan star where it's halfway through a 10 billion year lifespan. But red dwarfs last even longer. We're talking hundreds of billions of years, perhaps trillions.
Where are they in the evolution of a star? Where it's like our star is going to become a red giant. So
Right.
there's an evolution in progress. So, oof. So what do,
Here's what it kind of looks like.
oh yeah, I've seen that. Yeah, but.
Yeah, the Hertzsprung-Russell diagram.
Yeah.
Main sequence stars run along
Like
this
a-
line, and
Yeah.
they do evolve quite dramatically. So our sun, for instance, was a nebula at first, of course, and then lived most of its life right in the middle of this chart. All these yellow stars. So it's actually graphed logarithmically with respect to our sun, having a solar luminosity being right in the middle and a yellow color right in the middle. So that's where our sun is. And then later on, the sun will expand. And so the color goes into the red. So it moves to the right and it moves up and it cools down. So there are 4 axes. There's the temperature and the color, and these are pretty closely related. Usually the bluer a star, the hotter it is. So if we have a bright bluish white star, it's going to be around 100,000 Kelvin or more. And a really dim red star is going to be perhaps under 3,000 Kelvin. And then we have luminosity and absolute magnitude. Absolute magnitude is how bright a star is from a given viewpoint. And the lower the magnitude, the brighter it is. So our sun's going to start in the middle. It's going to go up and to the right. And then the very last minute, like the last few 100 million years or so, it's going to plummet all the way down to the bottom left corner where we see this population of white dwarfs. Now, Deborah's question was, if you just start out as a red dwarf, do you evolve at all? Or what does your evolution look like? And you pretty much stay on this bottom curve here. So red dwarfs are going to be at the right side of this curve. Very low luminosity, very low temperature, and a red color. And they evolve so slowly that we actually don't have much data to even graph, because the universe is only 13 billion years old. We've never seen a red dwarf fizzle out, and we won't for another trillion years perhaps. So these are really hard data points to put on the graph. We can only really estimate how it evolves. Who knows? Red dwarves may do something really crazy at the end of their lives, but we would never know because it hasn't happened yet. And one of the other puzzles of the universe is this red sky problem, which is another thing I was interested in after watching this.
What's the chemistry of a red dwarf? Is it also hydrogen to helium?
That's right. Yes. The red dwarfs operate with the same fuel. It's fusing hydrogen into helium. Now they have much less hydrogen to start off, but since it's not that hot, not a lot of hydrogen is getting fused into helium. The rate of nuclear reactions is far less than what goes on in our sun, for instance.
Is there any reason to think that the percentages of stars into these different types of stars in our local group is any different than the percentages on average in the galaxy?
So I think what I've learned, and this was now 5 years ago, I took a class in undergrad called Galaxies. It was just called Galaxies, and we learned all about the physics behind them. And galaxies actually have different populations depending on what they
The
look
age
like.
of the galaxies and the type of
Age of the
galaxy.
galaxy. Yeah, we see that spiral galaxies have larger populations of large whitish blue stars, and elliptical galaxies tend to have higher populations of older red stars. And we think the reason that is spiral galaxies evolve into ellipticals, and so ellipticals are going to be typically older than the spiral galaxies and will contain older stars. It's really hard to draw cause and effect because we only have a very limited time to study the universe. Just think, even just the age of humans is a blink of an eye in the age of the universe. And we don't have that much time to wait. We can't just sit around and wait for stars to evolve or galaxies to evolve. All we can do is study many, many galaxies and try to form patterns and predict, okay, this is what happens when a new galaxy is formed. Here's what the stellar population is going to look like. And so here's a paper. What I was also thinking of in the last few days is the red sky paradox. And we say most stars in the universe are actually red dwarfs. They outnumber stars like our sun, 20 to 1. And the paradox is like, how did we end up with the sun? Why didn't we get a red dwarf star? It would have been so much more likely for us to be orbiting a red dwarf.
Are you going to answer that?
It's really hard to find a resolution. It's sort of like the
So-
Fermi paradox.
Mm-hmm.
So the red sky paradox is that question, huh?
Yeah, red sky meaning we would probably have a reddish sky if we had a reddish star.
Right. Yeah.
So that's, at least probably what Kepler 1649 would look like. Here's an image of what it would be like to live on that planet. So because it's orbiting a red dwarf, you see the sky is sort of like Martian almost. And you even see another, that could be a moon or an inner planet over here.
Well, why is the Martian visual
Iron.
similar with, our star not being a red dwarf?
Iron.
That's, all the iron ore dust that accumulates into the atmosphere. So Mars does have an atmosphere, although it's very tenuous. Dust particles do get caught up in that atmosphere and gives it like this auburn color, I guess. Yeah. Rust looking.
But Mars used to have a real atmosphere with a magnetic field and
That's right.
an active core.
Yep. And we discussed this a few weeks ago. We said, Mars
Yeah.
used to have a convection going on in the interior, and that was powering a magnetic field. But Mars cooled off, the core cooled off, that magnetic field,
Okay. Can you let OAN in? Can you let OAN in?
Oh, I see it. I see the thing now. Yes.
Okay.
Welcome, man.
Hello,
Hi.
Hello. Oh, and this is my cousin Gwen.
Hi,
hi Gwen.
hi, Owen.
Are you helping Deb out with her post-operative course?
Yep.
So much. Totally impossible without her.
Things went well?
No, so far.
Good.
Yeah.
We can see a little bit of hair from each of you, but not both of your faces.
Okay, so here's a Gwen. Can you see yourself there?
No, I'm seeing her.
Keep talking.
Oh,
It clues into your voice.
okay. I think she's doing remarkably well from, really tenuous situation.
Yep. Thank you for coming up and helping. Now, what do you guys solved so far with the sci-fi?
Yeah, so we've been talking about habitable
I am
exoplanets.
Get some meds. No.
Okay.
Yeah. I'm
And-
listening, but I'm gonna go get some Tylenol.
No problem. Yeah, oh, and we've been talking about habitable exoplanets,
Mhm.
and so far we think Kepler 1649c, I know it's not a very creative name, is the most similar exoplanet to Earth. It's almost the exact same size, and it orbits around a red dwarf star.
Hmm.
And we were looking at a picture of what that might look like standing on the surface, and it kind of looks a little Martian. It's got like the red sky going on. And then we said, well, Mars is in our solar system and we have the sun. It's bright and yellow. Why is the atmosphere still red? And that's because Mars has the iron oxide on the surface, and some of that dust gets kicked up into the atmosphere. And then we were explaining, Mars used to have a pretty abundant atmosphere, but as it cooled down, convection in the interior stopped and the magnetic field went away. And therefore, the radiation from the sun kind of stripped away Mars's atmosphere. And so now it's left with a very, very thin film, if you will, of carbon dioxide, argon, and oxygen. Okay.
How far away is Kepler?
Kepler 1649 is
Or how far away is the host star?
300 light years away.
Close.
Is it in our
Close.
galaxy?
Is it in our galaxy?
Yes, because our galaxy is approximately 80,000 light years across.
Mhm.
So yeah, this is our next door neighbor in galactic terms, but still we're talking about a quadrillion miles.
Is it in our local group?
Yes, because it would be in the Milky Way. Kepler 1649.
Oh yeah, the local group is all the galaxies. Is it in the spiral arms? I guess it must be. It's only 300 light years away.
Wonder.
I'm sure it has to be.
Okay. So Kepler mission, you see this little blue sector coming out to
Yeah.
the left.
That's all
Let me
they've
try to
looked
find it
at.
again. Yeah, so this very
Got it.
tiny area the
Right.
Kepler mission searched for. Try to find it again. Wow,
Yeah,
it's
that
a
was
lot.
a
Show
good
me
picture.
again.
That was a good
Okay.
picture, that first picture.
All right, we'll just look over here. So it's the one off to the left, 3,000
Yeah,
light
there.
years in scope. So it's in this arm. It's in
Right.
the same arm as us.
Yeah, it's just very, very close.
Mhm.
The Orion arm.
Mhm. And so in this movie, they were looking for a habitable satellite, the 23rd or 21st of Jupiter or something.
Oh, right. Yeah, it was some weird satellite, and I think that part is fictitious.
Yeah.
Let me take a look at it
Meaning
again.
moon.
K23.
Yeah.
Yeah, so
Sweet.
that's definitely fictitious because anything other than the 4 Galilean moons is really just like asteroid sized. We're talking pebbles
Got it.
in comparison. But yeah, you can say maybe this is a satellite similar to Europa or Titan. And yeah, so if let's say we can't go that far and 300 light years turns out to be way too much of a hike, then yeah, we may have to settle for something in our own solar system. And Titan or Europa or even Mars would definitely be our first choices to inhabit. And now,
Where was everybody going in that when they took off at the beginning? Where were they heading to in that?
Home and to live underground.
It was underground. Everybody was going
in his base, I think. Was that right?
What?
In his
I don't-
base?
underground. It wasn't clear to me where they were taking everybody to try and be safe. I don't know if it says it in the plot summary. It just says
Um,
evacuation of the base.
Well, since everyone was going to die, I thought they just wanted to go home. But there was,
Specified disasters like that. So
yeah,
we're contaminated with
does it say radiation? 'Cause-
ionizing radiation.
Yeah,
And it says unspecified, so we don't know exactly how this disaster was caused. You know, it could be a solar flare, it could be gamma ray burst outside the solar system, some cataclysmic event. And which is actually one thing I wanted to talk about is, you know, what if we do encounter a catastrophe that wipes out, I don't know, 90% of humanity or even more? Can we rebuild society if, let's say, all the crops fail, all the infrastructure is vaporized, and the vast majority of human life goes extinct? What can we do? Is there a backup plan?
A lot of sex.
Yeah.
a lot of what?
Sex.
Oh, well, yeah, the other part of the sex part is a man, a woman, and their daughter are going to repopulate Kepler 23.
They're going to repopulate K23
Yeah,
Jupiter.
yeah.
How could they?
Well, yeah,
It's
yeah. So seed, we have the seed bank up in Svalbard, but we have assorted sperm banks. But how are you going to get the mitochondrial DNA?
So yeah, I guess there's a couple scenarios to consider. The first is there's a few people left, maybe 1,000 or so humans. Or the other scenario is there's like one person left.
That's a little trickier.
It is.
Parthenogenesis doesn't work so much with humans.
Right.
Well, you know, they could have had a son next, and then, you know, even though
Little
it's,
insert.
yeah, totally incestual, the son and the daughter could have had more kids and da 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 da.
Well, the pharaohs did it, right?
Who are the pharaohs?
Egypt.
Oh, the pharaohs in Egypt.
Yeah.
Yeah.
Not
yeah, but there were many wives. So there
they were wives were sisters. They married
Oh.
their sisters.
Oh, got it.
You know,
Right.
if you get a divorce, is she still your sister?
Depends on whether or not you're in Utah.
That's good.
Right.
Oh, Ryan, you were saying there's another way. What's the other way?
Well,
Storing?
Yeah, the only thing I was thinking of is food. I mean, that's going to be huge because forgetting needing to repopulate the earth, how is anybody going to survive? You know, do we have to start from square one like the Mesopotamians did or the cavemen? And you know, this bank in Norway has about 1 million crop samples that are preserved, and it represents over 10,000 years of agriculture starting from the very beginning.
Whose idea was it to do that?
It looks like it was a 3-party agreement. So the Norwegian government, someone called Crop Trust, and then Gene Resource Center. This interesting thing, it costs, I think this is maybe an annual cost or total. It costs over $200,000 to maintain this thing.
That's bogus. You can
200
visit it.
For the year would be peanuts.
Yeah.
And so here's what it looks like. It's like a gigantic library. So you have all your rice, your wheat, your peas.
Not
Like-
meat, it's seeds. You would not have meat.
No, I didn't say meat.
Wheat. Oh,
Wheat.
wheat. Yeah.
Yeah.
And also things that we consider heritage rather than commercial. Things that we don't grow anymore or very minimally.
That's
Yeah.
our dog, Ryan.
Okay. Oh, nice. The other thing is, let's say you have access to all these seeds. Great. You have all the food you can imagine, but you need to plant them. You need to plant the seeds. And the seeds are only going to germinate and be successful crops in certain parts of the globe. You're not going to be able to grow pineapples in Scandinavia, and you're not going to be able to grow like corn in, I don't know, Brazil. Maybe you can grow corn in Brazil. I think Australia or
But-
something.
And if the disaster has been radioactive fallout, you may not be able to grow anything anywhere.
Or you
Yeah.
grow lots everywhere.
Oh yeah, or like you get like mutant plants or something.
It's like Chernobyl.
Imagine that.
They'll grow, but you don't want to eat it.
It's a very complex problem.
Yeah.
Definitely.
Did
Yeah,
this,
radioactive fallout would be.
Did this seed bank have a purpose?
It's really just for
Yes,
emergency.
you save the seed.
This is literally our last resort if all goes south.
Yeah.
So this is really break in case of emergency kind of thing. So we dedicated a lot of work and money as backup plan. This is like our insurance for our planet life insurance.
It's a little bit like the Mormon vaults in the Wasatch Mountains.
What about I don't know, talk.
Do you know about the Mormon vaults?
No.
Well, these are mostly records, and they're kept in the Little Cottonwood Canyon, up the Little Cottonwood Canyon on the north side of Highway 210 or 212. And there are little roads that go up there that are gated and protected and everything. And they have created these enormous vaults inside the granite. They're completely temperature controlled to 57 degrees. They are preserving the records of the Mormon Church and many other things. I don't know what qualifies to be able to go in there.
Well, like people's genetic or ancestry.
Yeah. people's
and-
ancestry, original records, etc.
Hmm.
I actually don't know. I should probably email Alan Horowitz and find out what he knows about it. What goes into the Mormon vaults at the WAS, because it's all about preserving history. And they may be putting genetic material in there these days.
And all of us, the Auschwitz murdered.
The what?
The people that were murdered in Auschwitz that they converted after death.
Yeah. And you know, it's just one of those in the mountain, like this Norwegian thing, preservation places. I don't know what else they have in there. Knowing the Mormons, they're not going to let the Norwegians outdo them.
Granite Mountain Records. Yeah. I never even knew of such a thing.
Yep. Oh, that's a good picture of it. A lot of my
No,
friends are climbers. Yeah, good for you. And they, you know, there's restricted areas around there to climb.
So this is, yeah, this reminds me of like the golden record that we sent out to space. Sort of just has an archive of all of our history on a digital format.
Mhm. And
Interesting.
they're trying to preserve it in a way that decreases any, they've got microfilm, they've got whatever, I don't know what else they have now that the technology has increased,
Well, it says they're digitalizing it now.
but they're trying to preserve it so it doesn't decay. That's the whole point.
Hmm. Mhm.
But
Well, having just driven by there, it looked so sedimentary. I'm surprised there's granite in there. But what do I know?
oh, there's granite. It's
Yeah, especially if it's called granite. Yeah.
if
Granite
you
Mountain
go up
Records.
the Little Cottonwood Canyon,
Hmm.
it's in the first third of the climb up to Alta on the left side, on the north side,
Hmm.
and it's incredible climbing. It's incredible climbing territory,
Hmm.
but the climbers have a
Hmm.
different route they have to go, and they can't go within a certain amount of there, and
No.
it's
So
protected.
Ryan, did you have in other area on this movie?
Yeah, the one question I had was just about the second asteroid strike that injures Maya and
Mhm.
how they got caught in, you know, basically a collision with an asteroid. I wanted to like get your thoughts on that, or anybody's thoughts.
Well, that was interesting because I was going to raise that too. That whole issue came up with, you know, how do you navigate in outer space? We've been talking about that last month or two with, you know, as opposed to having GPS on Earth, you know, they, I guess they were tied into navigation from K-23 on Jupiter, the satellite,
Earth.
to back to Earth, and then the Earth navigation failed or something with everything screwing up, and it screwed up their trajectory in their computers, and then they kind of got lost basically out there and had to recalibrate and go into the unknown zone, which I guess was the asteroid zone, and that's where they got hit.
Yeah, it's really interesting because we've never controlled, like manually controlled flight through outer space. Whenever, well, you know, we've only gone to the moon, that's it. And even if it's an uncrewed spacecraft that's being sent out to deep in the solar system, you only get one launch to change your velocity once. That's to get out of Earth's gravity. And then you're free to orbit the sun, and it's up to physics to decide where your trajectory is. And so you plan out what your trajectory is going to be exactly before launch. And it's really interesting to see how this could possibly be done manually, that is actually fly through space. That has never happened before. And I don't think it really can be right now. You know, we'd have to develop some other technology where you can pinpoint exactly where you need to head and use your thrusters accordingly, because that's all you can do in space is accelerate.
But you know,
And so-
theoretically, if you have thrusters, you'd be able to do it if you had a direction. Well, the other thing is, what about the Voyagers? How did they navigate through asteroid belts and now they're heading towards the Oort cloud? I mean, how did they dodge those bullets?
Well, I think it's pretty empty, to be honest. The average distance between the nearest two asteroids and, let's say, the main asteroid belt is on the order of 1 million miles.
Oh,
It's
Yeah, well-
extremely empty out there. It's not like you're going through a hailstorm. Although some movies falsely portray that, that's really not what's happening. You're going through pretty empty space and there's really nothing around. And so I think there's a very, very low probability that you do impact something on the way. And
mhm.
the course for Voyager was set way before launch. They said,
Hmm.
okay, if we launch exactly on this day at exactly this speed, leave the Earth, it will orbit the sun like this, because the only force acting on Voyager is gravity and nothing else. There's no
Yeah.
wind, there's no things that are going to bump into it and change direction. It's just floating out there around the sun. But of course, like, even if you were able to manually drive something through space, there's no way to tell where an asteroid is, because asteroids don't give off light and they don't reflect light if they're not facing the sun. There's no light to reflect, I should say.
This sort of stealth.
Yeah, it's just an invisible rock that could be headed straight your way. And that's another concern for near Earth objects. Like, we'll never be able to know whether an asteroid is going to come crashing to Earth if it's coming from the sun side, because we won't see it.
Mhm.
We can't see it coming.
Well, the other thing I'm thinking about is shields. I understand the space station, the ISS. I guess it's the main body, but I don't know this, but there actually are physical shields around the space station.
That's probably from microscopic debris. That
Yeah,
certainly wouldn't protect against a 2-kilometer asteroid.
yeah.
But
What
still,
about
yeah,
the
it's
tissue box size satellites that are going up?
Oh,
Starlinks. Is that what you're talking about?
Whatever there are new satellites going up, like there have been many of them, and now there's going to be even many of them. I don't know if they're being put up by
Well, SpaceX is putting them up.
SpaceX.
It's like 20,000 communication satellites. They're
yeah,
small.
but Stuart, there are also a bunch of, Ann said tissue box size that I think are going up by somebody else, whereas Skylink is bigger.
They might be going up by Skylink, and they might be going up by I don't think the Chinese are doing it, but they might be.
That's Skylink.
Starlink.
What about Virgin Galactic? Are they putting up any?
Stuart, did you buy yourself a seat yet?
No, did you?
No, I've been on the Concorde, that's enough. Actually, no, I really want to stay alive to get on the United one.
Oh, yes, it was recent. It was only 5 months ago. Virgin Orbit successfully deployed 10 cube seats. I'm not even sure what that is.
Yeah.
I never heard of a cube seat. Oh yeah, miniature satellite. That's it. Wow,
Yeah.
that's it. Tissue box size. That's it. 10
So
centimeter
so-
cube. Wow.
Are they all for communication, or are we going to be monitored by tissue box
Yep.
size?
They're listening to your echo. You know, your Siri,
It looks like
your Amazon.
telecommunications and I think that's it.
Thermal management? Oh, I mean, they're going to do away with global
Oh,
warming?
that's just, yeah, that's just how it's built, I think.
Okay.
Wow, that's cool.
It's going to be very interesting to see how the, I don't want to say the junk, but the stuff in space services us and, you know, thwarts us.
It's gonna get crowded. We're gonna run out of parking spaces soon.
So to speak.
But yeah, that was it. I think I
So-
also wanted to mention real quickly, if I had time, was what's it like living at the poles? Because we did have an Arctic base camp, and I think I don't really have anything to show. I just, off the top of my head, what I remember from watching this video. Right about now, since it's just after the summer solstice, it's completely dark in Antarctica. There's pretty much no sunlight 24 hours a day at this time of year. And what's really interesting, when it's completely dark out and the sun really doesn't rise, if it's a clear night, you get to watch the moon go through its phases continuously.
Hmm.
Because the moon will be always out for at least half of its phases.
Over what
So-
period of time would you be watching the moon going through its phases? A month?
29 days.
So half of that. So around 2 weeks, you would see the moon go from one side of the sky to the other. Because at the pole, you're not really spinning away from the sun or spinning towards the sun at this time of year. You're kind of just completely facing outward. You're facing away from the sun during the summertime. And so you'll watch the moon go from first quarter to third quarter. You'll watch it go like halfway lit, full moon, and then the other half lit. And you can watch that over the course of 14 or so days,
Wow.
nights.
Huh.
Assuming it's clear. It's they're hard to find places in a forbidden tundra where you actually have a clear sky, because usually just snow is being blasted by you at 100 miles an hour, and I don't think you want to stay outside that for that long when it's like minus 80. But yeah, that's just something I learned a couple weeks ago. I thought it was interesting to share.
Yeah. Very.
It's the closest thing we have to our inhabitable it's the closest thing in our inhabitable Earth we have to these planetary environments.
Hmm.
Yep.
So what about Iris? Was that
Ah,
an hallucination? The little girl?
yeah.
think so.
Yes, it actually says it was.
Oh,
even though
yeah?
we-
Yeah, when she did the drawing.
Well, the whole thing, the whole,
She never spoke. Right?
well, she spoke a few words, but
This kind of explains.
Oh.
That still can be a hallucination.
It was, in the last paragraph, it's talking about the story behind it, that she is the daughter and that he chose not to meet. So he's talking to her as an adult, even though he's seeing her as a child in his hallucinations.
Well done.
Yeah. And then there's a bit in the beginning just to confuse you about when they're getting on the helicopter and, oh, where's my daughter? Where's my daughter?
Right.
And of course, every 9-year-old girl wants to spend several weeks filming with George Clooney.
also the daughter, when she said, "Where's my daughter? Where's my daughter?" I thought she said a name at the beginning that was not Iris. It was another name.
I think you're right.
Anna.
Yeah,
Yeah.
yeah.
And Hannah was a palindrome.
Yeah, but that's from another movie.
Oh, really?
Didn't we just, yeah, Arrival.
Arrival, right.
Hannah, yeah,
Yeah, I thought it was
Oh,
Anna.
because it was back,
Hannah.
yeah, backward, Hannah, yeah.
yeah.
Mhm.
Hmm.
Huh.
That's all I really had to share for this movie. Habitable exoplanets, and then global catastrophes, and finally, what's it like to live in Antarctica?
Yeah. We have, Stuart, you know Tim and Rosie and Owen? They, he is a nurse here and she,
Oh, yeah, Tim and Rosie.
yeah,
They're black belt karate people.
yeah, right, and Tai Chi. But so they live in Jackson for many years now and they worked and met in Antarctica over many research seasons.
Hmm.
So,
I didn't know that. Rosie was the one that taught Adrian, right?
Yeah.
Mhm.
but she's a
Correct.
PhD in,
I had no idea.
paleo pollen ice core stuff.
No
That's
kidding.
what she was doing there. And Tim was, the medical liaison on some of her expeditions.
Huh. I was wondering how they met.
Yeah,
Who else was a doctor down there for 6 months at a time was the guy he was a hospitalist at the hospital. And his name is escaping me.
it's not Tewksbury or whatever.
What?
No, the only name of guy I've met there is, I don't know, Tukes, Tuzinski, yeah, I don't know,
I can't remember either.
yeah. But anyway, so I didn't know. Huh. But we have a bunch of Antarctic livers
Yes.
in town.
So getting back to the movie for one last comment,
Yeah.
it's hard to imagine 28 years from now, we're going to have the capability to send a ship like that out to Jupiter.
That's right. I don't mean to be a pessimist, but I highly doubt it. I don't think
We're not going to get to Mars even. We might not get
That's
humans
right.
to Mars.
We gotta get to Mars first, and then
Yeah.
then let's talk.
It might well be 2049 before humans really set foot on Mars.
Well, there's another thing is that how far out is catastrophic destruction of Earth going to happen?
That's a good point. Yeah.
That we
It
have
could be
Yeah.
sooner than we know.
Yeah,
Yeah.
but we did get rid of Trump.
we started to get rid of Trump, but he's like a comet. He's got a big aftertail. I'm sorry.
Tail is the word.
What is ionizing radiation that could have caused this catastrophe? Is that something that is due to,
That's like
That's what-
X-rays and gamma rays. So
Yeah,
it will destroy human cells.
right, so is that because we've screwed up the ozone, or
No,
because
it look, Stuart, there was a transient picture of a bunch of red zones like nuclear.
Yeah.
Multiple nuclear warheads is what it looked like to me, like a fail-safe. That happened all over, and Clooney says something about it was an accident, but we screwed up. So I think it was
human caused.
human cause, maybe not intentional, maybe, who knows, you don't know that, but it looked like it was multiple site nuclear disaster.
Yeah, I
Because it
remember
was
that picture.
reaching Antarctica.
Yeah, because the radiation, there were a bunch of like red spots all over the globe,
Right,
and that
Yeah.
were diffusing.
That was the picture they had from the interplanetary craft Ether. I think
And it's
put-
not unlike,
Well, that's a
that picture.
different one. That's a different picture. That was of Earth, a visual of the Earth, but the other one was much, much earlier in the film and was more like a diagram.
so it's not unlike what we're experiencing here, having a big condominium tower fall down and crush. That's like a little spark. We could have so much more of that in the environment in ways that we are not prepared for,
Yeah,
that start to very slowly, besides the tail of the Trump comet hitting us politically, we would have these other things going on.
Well, Ryan, keep up the good picking of films. These are great films. You
Yeah.
make
yeah.
good points on them.
All right.
Did you,
Glad you liked
did
it.
you guys, yeah, did you guys do something last week?
Yes, we did, what was it called? Magellan.
Magellan.
Magellan, yeah.
It was worth looking at them.
Yeah.
It was an artistic film, as Ryan says. It's true.
The question is it less artistic or more artistic than The Day the Earth Stood Still?
Mm.
We were discussing that on our way off the river today
Huh,
while we were stuck in traffic. I'm
yeah.
going to try to get on my book club for the American Psychiatric Association, but I'll see you guys.
See you guys next week.
All right.
Enjoy
Yeah.
your new car. Get your back.
Yes.
Keep getting better.
Oh, what did you get?
A Subaru Forester.
There you go. Very efficient car.
Did you get a job in Florida yet?
Yes, I was hired last week
Congratulations.
in
So-
Melbourne, Central Middle School, teaching
Oh,
math.
Fantastic. Good for you.
Thank you.
congratulations.
Appreciate it.
Yeah. So when are you gonna go down? August-ish? Or,
We'll be down the last week of July.
huh?
Enjoy.
Yeah,
So much.
yeah.
Ta-ta.
It's the beginning, the next beginning.
Yeah.
Yeah. Yeah. Fantastic.
Good luck. I'm going to leave.
Yeah.
Take care.
All right.
Yeah. Toodaloo,
later.
you guys.
All right.
Bye.
Bye.